Hey everyone, my name is Brandon West. We're here at AWS Reinforce, joined by Merritt Bear.
Hi, thank you. My name is Merritt Bear. I am a principal security architect here. I work with global accounts, which are some of AWS's largest customers around the globe. And Brandon and I actually went to high school together. Little known fact.
Yeah. Both ended up at AWS.
Both did.
If you happen to be a Heritage High School Eagle in Littleton, go Eagles.
There you go. Yeah, exactly. So fun background there. And we are in Boston today. And I came to Harvard after Heritage in Littleton. And so this is somewhat near and dear to my heart in the sense that we're here in Boston. And also that we're talking compliance. I went to law school, and so a lot of this is actually foundational in terms of no one's going to do anything on AWS unless it's secure. No one's going to do anything, in a compliance framework sense unless you can satisfy those demands.
Yeah. So what are we going to be talking about security-wise today?
So today we are going to be talking about automating compliance, and there are a lot of ways that could be interpreted, but I'm speaking specifically about the ways in which, because the cloud enables you to use formal math, you can know that you are compliant as a fact in the world, rather than the kind of old-fashioned way of checking boxes and hoping for the best and constantly trying to check to make sure that you did what you think you did. Now we can know it as a matter of fact.
Cool. Well, I think let's dig in then, right? You've got a bit of a presentation for us.
Yeah, I've got a couple of visuals here, so hopefully this will help to illustrate. As I mentioned, we're talking about the wide landscape of compliance controls. So everything that you could consider around the world. AWS, for our side, manages in the shared responsibility model that is security and compliance in the cloud. We manage the bottom layers of the stack. So for customers, you can access our compliance documentation in AWS Artifact within the AWS console. But customers, for their side of the shared responsibility model, which is from the hypervisor on up through, so layer 4 on up through layer 7, they will need to manage their compliance in the cloud for compliance frameworks like this array that's on your screen.
And when you talk about those levels, you're talking about the open standards interconnect model of a network, right? So you're saying basically the top end is going to be your application. The top layer is like all of the code that's running. The bottom layer is like the literal physical infrastructure and packets moving.
Exactly. So the value proposition of the cloud is that AWS, or your cloud provider, manages the bottom layers of the stack. So the concrete floor, all the way through layer 4, which is the hypervisor. So we're talking about physical, data centers, racking and stacking servers. We're talking about HVAC, fences, staffing, et cetera. And so to be compliant, we need to have documentation around our practices there. And as I mentioned, we do have documentation there from third-party auditors and reports, including SOC reports, NIST, et cetera. So that is available to customers in AWS Artifact. However, customers still own those top layers of the stack. So layer 4 through layer 7, the software layers. Of course, that makes sense because customers know what they're doing. They need to have that malleability to be able to architect for security and privacy in the cloud.
Makes sense. And developers were hopefully owning the security of that part of the stack anyway. Not always the case, but hopefully.
Well, I will be doing another quick talk this afternoon on DevSecOps, which will get a little more into the development pipeline and how you can be engendering a culture of security within that. But certainly for folks who are affected by or who fall within compliance frameworks, it's a non-starter. If you can't satisfy the compliance requirements, then you can't be doing business. And so that's one reason why we are so eager to demonstrate that you can be compliant in the cloud. And frankly, why cloud is such an enabler, because you can do compliance in much more automated, much more scalable ways.
Yeah. Well, let's talk about some of those.
Yeah. Sounds good. So I'm going to be using something as we talk about compliance as code and automating compliance, I'm going to be using a toolkit, if you will, called automated reasoning.
Okay.
And this is something that we use internally at AWS. We have a group called the Automated Reasoning Group, of which Byron Cook is the leader. And this group uses formal methods to verify provability. So in terms of what that means in practice, it means that you can scope down really vast problems into solvable problems. And then you can know, as a matter of fact, whether the math resolves or not, whether something is true or not. So take, for example, the infinitude of primes. No one goes out and tries to count every prime number. We accept that if you believe math behaves the way we think it does, then there is an infinite number. So we find ways to scope down into truisms, what might otherwise be kind of unfathomable problems, or things that computers could spin forever in terms of like Turing's halting problem. So making the undecidable decidable. And the benefit of using a tool like formal reasoning or automated reasoning is that you can know things as a matter of fact. And I'll explain that a little more as we go.
Okay. So does P equal NP or not?
Oh, gosh.
Sorry.
Exactly. Okay, so part of this, though, is just an inherently cloud capability because now the customer, goes into the AWS console and they can deploy code. So, for instance, on the screen here, we have a CloudFormation template that creates a VPC and adds an EC2 instance in a single subnet. From the customer perspective, you can grab this code and deploy it, and you all of a sudden have physical resources running, and you have the compute power that's associated with that. And so that's what we mean when we refer to infrastructure as code. From the experiential side, what you're putting in is code, but really what you're getting is, really tangible outputs. Well, once you have infrastructure as code, then the way to secure it or to ensure that you have created an architecture that is what you want it to be, that has constraints and the security that you need built in, that means you're looking at security as code. So, for instance, here we've got a JSON IAM policy that has very specific requirements for access. So it'll allow access using MFA during specific dates. You can get very granular with your IAM. And then you can get to the point where you encode policies as logical formulas. So this is the basic building block of what I'm talking about when I say compliance as code. What I mean is that you can know from looking at your policies whether or not an action can happen.
Okay, that makes sense. So basically, when you have a policy like this that's well-defined and you have the system on which it's going to run, you can prove that you're going to be compliant based on that policy. Am I following?
Yes, you are following. We will give an example in a little bit, which I think helps to concretize it. But basically, you can now know by looking at your code what you have set as the parameters in terms of permissive or not permissive actions. And mapping that to your compliance requirements, then you can just know as a matter of fact whether or not you are compliant. Of course, it sounds a lot easier and simpler when I say it than it is sometimes to implement.
Yeah.
But getting to a lot of simplicity takes a lot of hard work, and I think that's true here as well, where the complexity that it takes to get to something simple is not to be acknowledged, but it's also worth it because at that point you can actually have your code be the continuous witness to your compliance standard.
Wow, I like that.
Cool. So in terms of what this means, what it means for customers can mean that, one, they just know that they are compliant, that they have met certain requirements. But practically, that also means you can decrease costs, you can increase your scalability, you can be more resilient, you can be more nimble, and whereas compliance is often perceived as a real block to the usability or to the innovation pace, being able to use compliance in a cloud world means that you can automate it more, and that means that you can better formulate your approach, which means that in the long run, you're faster and more nimble, and yet you maintain your constant compliance standard.
Yeah, and I think hopefully that feeds into some of what we heard at the keynote earlier today, where we want to make security and compliance part of the culture of everyone's work, whether they're a developer or someone who's setting those standards, whatever that might be, and not have it be sort of a goal where different groups within a company can be at odds with one another. And I think once you've created the systems that are automated, you remove a lot of that friction because now it's in code. You can see it, and then if you deploy something that's out of compliance, you get a response. You can see that somewhere on a dashboard, hopefully, if you've instrumented things correctly.
Yep, exactly. So whereas, maybe 10 or 15 years ago in an pre-cloud mentality, you would have a community of folks who check your deployments after the fact to ensure that they're compliant. Now you can really build it in as part of the fabric of what you do. And in keeping with the requirement that compliance be an ongoing, maintained state of being, you can also know, you don't have to have the manualness of an audit for you to know that you are remaining compliant. Mm-hmm. You can actually know that through the code you're deploying.
Super cool.
So part of this means that you can get to the point where you have intent-based governance. So you just take what you want to deploy and turn it into policies and turn it into code. And in an ideal state, you're actually developing access controls and able to deploy and maintain your control in a way that just lines up seamlessly with your intent.
Mm-hmm. And thinking in the future, intent-based everything. Like I imagine in 10 years, some of us may not write code. We might have a system where we explain our intent and that machine learning generates some code. So I love this idea of intent-based everything. I think it's really interesting way to think about the future, but I hadn't considered it in terms of governance yet.
Yeah, that's absolutely right. I think that as we see that, automation allows humans not only to scale quickly, but also to avoid the kinds of manual errors that humans have when you fat finger something, allowing humans to really translate intent into computers doing what they do well, which is writing the specific code or policies around it. I think we can expect to see more and more intent-based actions as that will free up developers, and it'll also allow us to use resources in a efficient manner.
Cool.
So getting a little more specific about what this really means, and one of the tools that we developed internally and have made a customer-facing tool is called Tiros. And Tiros does formal reasoning about network configurations. So without having to send a packet over the wire, without ever having to get into the messiness of finding out whether you did what you think you did, you can know whether your configurations match your expectations. So it makes API calls, it describes the network, and you get semantics written in logic. So you can query this, you can use constraint problem solving, and we have now embedded Tiros into Inspector, among other sort of service applications, but we also use it for compliance in particular.
And so this would be a way to verify that a network configuration is compliant without actually having to test it. You could just know through the proofs that you've been able to come to as a result of the constraints you put in place that it does actually comply.
Exactly.
Cool.
That's So Tiros works at the network level and describes networks configurations. We have another tool called Zelkova that works at the policy level and will compare, for example, IAM policies and tell you which one is more permissive than another. So those two are the customer-facing examples that we have deployed, but automated reasoning is really more of a toolkit, and I think we should expect to see it continued to be deployed in situations where a high level of fidelity is important.
Okay.
So where you need to know as a matter of mathematical fact, and where approximations are not good enough, we'll see more formal methods.
Cool.
So here's an example getting really specific about how you could use this to do provable security in a compliance framework standard. So using PCI Compliance, the payment card industry standard that is now prevalent, some of these network-based controls include the prohibition of direct public access between the internet and a system component, specific insecure ports, and then a requirement that you review the firewall and router rule sets periodically, in this case every 6 months. So we were able to actually automate these by taking, for example, this rule about the prohibiting direct public internet access and allowing us to write that as a policy so that we know as a matter of fact whether or not you are compliant with that. So this, and if this language on the screen doesn't mean anything to you, that's fine, but it should be, the goal is to have it be, quote, eavesdroppable, so that you can kind of even if you couldn't write the policies yourself, that you can understand what is written there, and that you can then interpret whether or not you're compliant in terms of a true-false.
So I think I figured it out, basically. For all of your instances,
right,
if they have a tag with a certain key,
if it's a card holder,
it's called card holder tag.
Yep.
Then don't let that instance connect to the internet.
Right. Exactly.
Cool.
So
enough,
exactly. Yeah. And so these are directives. You can also get descriptives and find out whether you've done what you think you've done, which is basically another benefit here of being in cloud, that you've got this unprecedented visibility and that that there's no rogue server under someone's desk. So your tactile ability here to have every API call logged in CloudTrail, even those that fail, to have CloudWatch monitoring your CPU usage, et cetera. And then as of today, Security Hub is GA, so you can expect to see these rolled up within Security Hub, and the ability for customers to basically use logging and monitoring to both attest to their auditors that they have done what they needed to do, and also to know internally that the controls are working in the way that they believe, as a comfort, if you will, but as a reactive way to ensure that you're setting up your policies consistent with your expectations. So this is getting further into your full visibility and your logging, and if folks are using other AWS partners, there's also integration with partners like Splunk and AlertLogic, et cetera. So in a sense, it's like, so what? Is always the question here.
Yep.
Although we're geeks and we think this is cool, it also serves really important purposes. As I mentioned earlier, first, it just changes the perspective of compliance from being a check the box and hope for the best to being able to, at least for some of the controls, to know as a matter of fact whether you've satisfied those. And then to continue thinking through what you can automate in terms of how to describe the requirements in code. And then you will know that you have set your compliance as code, or you will know continuously that you are compliant. And as you mentioned, that means that you can set it through the development lifecycle, so it's not an afterthought. It's not something where later your lawyers or risk officers have to come through and hope that they can make your services compliant. It's the kind of stage in the pipeline where you should be building these requirements in so that nothing gets built without the compliance considerations. And then meanwhile, the way that the cloud works means that you can also allow for enforcement of that. So you can require that your architectures be compliant with the kinds of specifications that you've written, and this could be requiring, among the requirements that folks do is to, for example, enforce an audit trail. So whitelist CloudTrail in your AWS org's SCPs or something. But it also means that you can get very granular about actions and non-actions that you can allow, for example, that PCI example with internet access.
Cool. Well, thank you so much for the awesome talk. I learned a lot. I literally did not know what automated reasoning was before this conversation. So thank you for enlightening me. Hope everyone out there enjoyed it. And thanks for watching.
Definitely. It's a cool area. There is a provable security blog too, so if folks want to look up some more applications and storytelling around the way that we're using this, check out the blog.
Great. Thanks, everyone.
Thank you.